Photons are one of the most important things for most living organisms to survive. It lets us able to see and absorb information from our surroundings. Photons are useful, but they can also be dangerous. It can mutate our cells and cause cancer. Why is this? Photons is one of 18 particles in the universe, 16 of them being confirmed and 2 of them being unconfirmed. Photons were theorized by Albert Einstein. It is the smallest particle known to exist, but can still be slowed by matter by a bit. Photons are also the fastest particle in the universe at the speed of 299,792,458 meters per second, also known as c. When the photon is created, it will always go at c, the speed of light. No other particle or matter can reach that speed or higher since the universe doesn't allow it to. Photons have a mass of 0, meaning that it weighs nothing. Photons cannot be split but can be created or destroyed. All photons are a wave particle, meaning that they are a wave and a particle at the same time. This table is called the electromagnetic spectrum that shows you the different types of wavelengths, meaning that they have different properties. The waves we and most animals see is called visible light, which is a small portion of the whole electromagnetic spectrum. Behind visible light is infrared, which you can see the heat of the animals. Red meaning you can detect more heat from the source, and blue or black meaning that there isn't a lot of heat. Infrared is also heat from the sun when you go outside. In front of visible light is ultraviolet. Ultraviolet waves are the third most ionizing wave in the electromagnetic spectrum. They are useful since it can give us vitamin D. It can also be used for finding certain liquids that can be absorbed by UV then reflected into visible light. There are many more wave particles in the electromagnetic spectrum, but these three are the most important ones. Visible light is the only set of electromagnetic radiation that breaks up into colors when in water, where the first evolved eyes happened millions of years ago. Photons are created when atoms drop from a higher state of energy to a lower one. When they lose energy, they emit it in a form of radiation. An electron with an excited state will drop from a higher shell down to a lower one and lose the energy. If an electron is in a lower state, it can receive incoming photons or radiation to go up a shell to get an excited state. When traveling at high speeds, your time will slow down more than a person sitting in one place. In the Hafele-Keating experiment, John C. Hafele and Richard E. Keating took 4 atomic clocks aboard a plane and flew around the world twice. Then compared the clocks to the clocks on the ground and found out that the clocks were disagreeing with one another and had different times. This led to a theory of how when accelerating towards the speed of light, the more of your time slows down. There is still no answer to why this happens, but this is led to be believed of one of the causes of dark matter. But what happens when you exactly reach the speed of light? If you somehow manage to reach it, it is believed that your time will completely stop and might never be possible to get out of. But of course, it is impossible, since the universe won't allow you to do it. Thanks to this theory, there are many ideas of how to get to the future faster than by waiting around. There is the famous Stephen Hawking theory of the train to the future. When you think of black holes, you think of mass being sucked into eternal darkness. But if photons have the mass of 0, then how can black holes be able to suck in something that is massless? Well, black holes don't just suck in mass, they suck in energy and momentum. Photons are energy and is constantly going at c, or the speed of light. That same, black holes are able to suck in photons.